Our topic for today is the volume and the surface area of prisms. And our essential question is, how can I measure the volume and surface area of prisms? Before we can address that question though, we need to do a little bit of vocabulary work to make sure that we're all understanding each other when we speak about these three-dimensional solids. So this vocabulary that I'm about to give to you is going to be for any three-dimensional solid, not just prisms, all right? So the first thing is, what is a prism? A prism is a three-dimensional shape that has two congruent bases and lateral faces. The base can be any shape. It could be a square, a rectangle, a triangle, a hexagon. It can be anything. And the bases, there's two of them. They're not always the top and the bottom of the shape. Sometimes your prism might be on its side. So it's just going to be which of the two bases or which of the two sides are exactly the same shape and size. When we're dealing with rectangular prisms, you can almost use anything as your bases. But when we have triangular prisms, it's going to be the triangles that are the bases, whether or not they're on the top of the side, top and the bottom, or on the sides. The next vocabulary word is lateral faces. Lateral kind of means side. So the lateral faces are all of the sides of a prism or a three-dimensional shape. For prisms, our lateral faces will always be parallelograms. They might be a rectangle or a square or a rhombus. Those are all parallelograms. They will not ever be a trapezoid or a triangle or a hexagon. They're always going to be parallelograms. And our third vocabulary word is bases. In a prism, the bases are congruent and parallel faces of a prism that connect to the lateral faces. This shape right here is an example of a prism. The bases are congruent and parallel to each other. In this case, these bases are regular hexagons. So you can see our prism can have any shape for the base, doesn't have to be a rectangle or a square. The height is the distance between my two bases. And you can see here that each of those lateral faces is a rectangle. And I'll have the same number of lateral faces as I have the sides of my base. So if it's a hexagon, it's got 6 sides. That means that I would have 6 lateral faces. So let's talk about how we can find the volume of a prism. If I want to find the volume of the prism, you may have learned about this in like elementary school or middle school math. And probably when you were introduced to these, you were just looking at rectangular prisms. And so they told you the volume was length times width times height. And for a rectangular prism, that's true. But what if your base is not a rectangle? What if it's a hexagon? I can't just do length times width times height. So instead, I want you to think of the volume as what would happen if you took the area of that base and you stretched it up, because that's kind of what your prism is. It's like taking that base shape and just pulling it up, and everything inside would be your volume. So the easiest way to talk about calculating the volume is to think of it this way. Your volume is going to be the area of your base. If that's a regular hexagon, then you would calculate the area of the regular hexagon. If it was a triangle, you would calculate the area of the triangle. If it's a rectangle, you'd calculate the area of the rectangle. And then you're going to take that area of your base and you are going to multiply it by the height. And that is how you would calculate the volume of a prism. When we're calculating volumes, our units are always going to be units cubed. So to the third power, because we have 3 dimensions. You've got the length, the width, and the height. So we need to account for all 3 of those dimensions in our units. So it would be units cubed. When we're calculating the surface area of a prism, your surface area is going to be the area of every single face added together. And when we are calculating surface areas, our units are going to be units squared. So this prism right here is an example of a rectangular prism. And in our rectangular prism, our bases are going to be rectangles. So I'm going to highlight the base here for you. Remember the base, there's 2. In this case, it's what I would call the top and the bottom of this shape. So that, what I just highlighted in yellow, will be my base. So it has a length of 11 and a width of 4. So that's what I'm going to use to calculate the volume. So let's start by calculating the volume. Remember, the volume is going to be the area of the base. So my area of my base is going to be 11 times 4. This is the area of the base. And then I'm going to multiply that by the height. My height is 7. So I can get my calculator out and I can do 11 times 4 times 7, and I get that my volume would be 308. And then my units are inches, so it would be inches cubed. So 308 inches cubed, that is my volume. Since it's a rectangular prism, I don't have to use the top and the bottom of the bases. I could use the front and the back as the bases, or the left and the right sides as the bases. But when it's a rectangular prism, I think that it's easier to just think about it as the top and the bottom being your bases. If it's anything other than a rectangular prism, like a triangular prism or a hexagonal prism, then your bases are going to be whatever that triangle, hexagon, whatever other shape it is, whether or not they are on the top or the bottom, or if they're on the sides. Now we are going to calculate the surface area of this shape. So when we're calculating the surface area, we are going to take the area of each face and then add them all together. In a rectangular prism like this one, we're going to have pairs of faces that are equal to each other. So the top and the bottom are going to be equal to each other. So I can find the area of one of them and then multiply it by 2. So let's start with the top and the bottom. Those are my 2 bases. Oops. I was saying bases and I started writing bases. That's not what I meant. I meant to write bottom. Oopsies. Top and the bottom, there we go. Okay, so my top and my bottom are going to be that 11 times 4. The area is 11 times 4. So that would be 44. And then since there are 2 of them, I'm going to multiply that by 2 to get a total of 88. And since we're talking areas, it's going to be square inches. So that is going to be what I have highlighted in yellow. Okay. Now let's do the front and the back. So I'm going to highlight those for you guys so you can see what I'm talking about when I say the front and the back. So here is the front. It's the rectangle that has a width of 11 and a length of 7. And the front and the back will be identical to each other as well. So I can find the area of one of them. and then multiply by 2, just like I did for the bases, the top and the bottom. Okay, so this time my length and my width are 11 and 7. So the area of one of them would be 11 times 7, or 77. And since we've got 2, we've got the front and the back, we're going to multiply that by 2. And that will give me 154 square inches. And then the final pair of faces that I need to talk about and calculate are the left and the right side. Left and the right side. So that's what I have highlighted in blue over there. So for that, we've got the dimensions of 4 and 7. So we're going to do 4 times 7. 4 times 7 is 28. And again, there's 2 of them, so I need to multiply by 2. And that would give me 56 square inches. So to find my total surface area, I'm going to add up those areas all together. So I've got 88 plus 154 plus 56. I'm going to add those together. And I get 298. And then since I'm talking about an area, I would have inches squared.